Hi everyone, this is a video for Math 105. I'm going to do a couple problems from section 1.4 in the book. That's the section on complex numbers. Problem 28 is divide and write in standard form, and they give you this fraction. 3 minus 4i is the numerator, and 4 plus 3i is the denominator. So some things to keep in mind. Notice this is a division problem, right? Because a fraction is division. Or divided by, right? Okay, and the other thing to notice is these two are in standard form. So standard form of a complex number is a plus bi, where a and b are real numbers. A real number is any number that you can put on the number line. So 0, 2, 3, it can be -4, it can be a fraction, it can be a square root, it can be some, long decimal that repeats forever or that goes on forever like pi. But it's a number on the number line. It's a number I can write as a decimal. And then notice that I is defined, well, the way I like to think of it is that I squared is -1. But you can also think of it as I is the square root of -1. Okay, that is a number that's not on the number line. It's a new kind of number, but we can take that number and multiply it by a real number. That gets what's called an imaginary number. And then if you take an imaginary number and add it to a real number, you get a complex number. Now, a and or b could be 0. So if b was 0, then a plus bi winds up just being a real number. And if a is 0, then a plus bi just winds up being an imaginary number. Okay. So this is not in standard form. So we've got to do the division. And this is sometimes, this is very similar to rationalizing the denominator when you want to put square roots into some kind of standardized form. So how do you do it? Well, you multiply top and bottom of this fraction by the conjugate of the denominator. So first thing is to notice we want to keep everything equal. So if I'm going to multiply and keep it equal, I have to multiply by the number 1. And the number 1 is just some number divided by itself. Right? So I can multiply by 4 minus 3i over itself, because this part here is just the number 1 in disguise. So I've got my original problem times 1. So notice this is, times the number 1. And when you multiply it by 1, it doesn't change it. That's why we get the equals. Now, why did I pick this? You pick what's called the conjugate of the denominator. So the conjugate is the same values, except for you switch the operation. If this is a plus, you make it a minus. If this is a minus, you make it a plus. Okay, so I've got 4 plus 3i, therefore the conjugate is 4 minus 3i. The reason you do this is the numerator will just be what it is, something that's equal to this, but the denominator will be the case where it will always be reduced to a real number, a pure real number. You've set it up because of the opposite signs, and these are the same, that when you do the distributive property, the outside and the inside terms will cancel off. And therefore, your result won't have any value of I in it. It'll just be a real number. Okay, so let's do the multiplication here. So I've got to multiply out the numerator, and I've got to multiply out the denominator. You can use any way you want. If you can do it by hand, because this is like a binomial, you could use FOIL. I like to use what are called algebra boxes. The boxes are just a graphic organizer to help me keep track of when I'm multiplying. So I make a little box. I got 3 minus 4i. Write that along the top. I got 4 minus 3i. Write that along the bottom. And then I split my box up into 4 pieces. It's a 2 by 2 because each of those have 2 parts. And now I have 4 partial products. So I multiply each of those 4 things. So this is similar to lattice multiplication, if you learn to do lattice multiplication. It's a graphic organizer for the distributive property. 4 times 3 is 12. 4 times minus 4i is minus 16i. Minus 3i times 3 is minus 9i. And now this is where it's tricky. So I have minus 3i times minus 4i. Well, minus 3 times minus 4, that's 12. And I times I is I squared. So notice that's 12i squared. However, that equals just negative 12. Because remember, I squared is minus 1. So that part's negative 12. Okay, so that means here my numerator is the sum of these 4 partial products. Well, 12 minus 12 is just 0. And negative 16i plus negative 9i is negative 25i. Now, I would have got the same thing if I used FOIL or some other method. Okay, let's try it for the denominator. If I make it a box, I got 4 plus 3i, 4 minus 3i. Same idea. Let's do the partial products. 4 times 4 is 16. 4 times 3i is 12i. Negative 3i times 4 is negative 12i. And then this one here, negative 3 times 3 is negative 9i squared, because it's I times I. And I squared is negative 1, so this just winds up being positive 9. Now, the important thing here is the I terms, the parts with i's in it, cancel off. So when I go to find out, I've got 16 plus 9, 25, but this I part and this I part cancels off. So notice the denominator is just a real number. And in this case, I gotta have a big equal sign, sorry. I've got negative 25i over 25. That reduces to just negative 1i, negative I. Woohoo, final answer. So notice that I want to think about it this way. Why is it in standard form? It's in standard form because this is 0 minus 1 times I. Just not writing the 0 and the 1. So here A is 0, B is negative 1. But when you have when you have 1 times a number, often you don't write the 1, and when you're adding or subtracting 0, often you don't write the 0. So just conventions. If you're typing it into MyMathLab, type this in, negative I. Okay, I hope that makes sense. Let's move on to problem 50. So problem 50 is to perform the given operation and write in standard form. So again, we want to write this as a plus bi. Standard form is a plus bi. Again, a and b are just real numbers. I is the symbol that stands for the square root of -1. Okay. Notice this is a difference. We're subtracting two square roots and they're being multiplied by 12. So we don't have, you could use a box, but notice when we multiply it out, we just use the distributive property. Now before I do that, I convert my negative square roots to multiples of I. So the square root of -12 is the square root of 12 times I. Now you can write the I behind it or in front. A lot of times when it's a square root, you'll see that they write the I in front. So it's just the square root of 12 is the real part times I. And this would be I times the square root of 4. And square root of 2 is just square root of 2. So watch out here, it looks a little tricky because there's this negative, but it's not underneath the square root. So this is not imaginary. This is a real number. It's the, where is this real number? Negative square root of 2. Well, like there's 0, right? 1, 2, 3. 1, -1, -2, -3. Well, negative square root of 2 is right around here somewhere. Negative square root of 2. It's approximately -1.41. So it's on the number line. So this thing here is just a real number. It's a decimal on our number line. Okay. Step 1, convert your negative square roots to multiples of I. Step 2, just do the problem. So I have to distribute. So I have square root of 12 times, well, actually I do have a choice here. If I wanted to, I could reduce. See, do any of these square roots reduce before I do the multiplication? So that's true. Or I could just multiply them out and then reduce. Let's do it both ways. So first, let's just multiply it out, like I was trying to say here. So I would have I times I, which again is I squared. So I'll just write it as I squared. And then square root of 12 times square root of 4. And now, then I have minus, there's no I here, so it's just I square root of 12 square root of 2, right? Okay, and then I would do I squared is -1, and square root of 12 times, so multiplication, you can rewrite that as the square root of 12 times 4, 48. And then square root of 12 times the square root of 2 is the square root of 12 times 2, 24. Okay, so you could do it this way, but then you want to reduce square root of 48 and square root of 12. So I don't know. Let's try it. 48, I'm looking for a multiple of a perfect square. So let's see, is that 16 times 3? I think it is, right? Sixteen times 3 is 48. Okay, so that's the square root of 16 times the square root of 3. And that's 4 square roots of 3. So this equals -4 square roots of 3. And now square root of 24, that is 4 times 6, right? Yeah. So square root of 4 times 6, that's square root of 4 times the square root of 6. That's 2 square roots of 6. So this is minus I times 2 square roots of 6. Now watch out, you could write this guy here as negative 4 square roots of 3 times 2 square roots of 6 times I. The reason a lot of times they don't write it this way because it's easy to get confused. Is the I underneath the square root or not? If you write it this way, it's much clearer that the I is not under the square root. So that's why even though it's A plus B times I, they're writing the I first. So notice that if this is our answer, here the A is this strange real number, but it's still a real number, negative 4 square roots of 3. And the B is actually negative 2 square roots of 6, because it's negative 2 square roots of 6 times I. You might ask yourself, do these two things combine? Can I combine square root of 3 and square root of 6? And they're not the same thing, right? You can only add or subtract roots if they're the same. It's kind of like when you have x's, right? Common term kind of situation. So since this is a 6 and this is a 3, you don't get to add them. You just leave it like that. That's the final answer. Oh, I just noticed there's actually even another way you might see this written. You might even see this written this way, where it's minus 2I times the square root of 6. So the reason you can see it that way is basically this part here is negative 1 times I times 2 times negative 6. And those 4 numbers are all being multiplied. It's the product of those 4 numbers. So you could rewrite those 4 numbers in any order you want. That's called the commutative property of multiplication. So whether you write it this way, or this way, or this way, it's all the same number. It's like that idea of if you write 2 times 5, that's the same thing as writing 5 times 2, right? So it's just which order are you writing the product of these 4 numbers. You could write it this way, you could write it this way, you could write it this way. Now if I explicitly want to write it so it looks like A plus BI, it would be this way. I hope that my math lab would count any of them as correct, because they are all technically correct. I think it would. Okay, so I hope these videos help